In section 7.2, proof-oriented triangle theorems, we're going to talk about two theorems that talk about angles of triangles. The first one is the no-choice theorem. And what the no-choice theorem says is if I have two angles that are congruent to each other, it implies that the third angle will be congruent to the other third angle. This should make sense considering that we know that all triangles are 180 degrees, so if these angles are congruent, then the leftovers should be the same. So therefore, A and B would be congruent. The second theorem we will talk about is angle-side angle. Angle-side is a theorem that proves the two triangles are congruent. And the reason it does this is based on the no-choice theorem. If we're given two angles and a side not included, it will prove the triangle's congruent. And the reason is, if we take a look at what the markings are, angle A is congruent to angle X, angle B congruent to angle Y, and then AC congruent to XY, we know that C would be congruent to Z based on the no-choice theorem. Therefore, triangle ABC would be congruent to triangle XYZ based on angle-side angle. And that would be the possibility in any proof that you have. You don't necessarily need to have the no-choice theorem. You can simply state angle, side. Looking at a problem from the book, number 14, we're given the following information. That AC is parallel to XY and that AB is parallel to CY. Angle ZAC is congruent to XAB, and what we were trying to prove is angle X is congruent to angle Z. So let's take a look at what it looks like on the graph, or on the diagram. From the diagram, hopefully you'll see that now ABYC is now a parallelogram because it has two pairs of opposite sides that are parallel. What you also know about a parallelogram is that the opposite angles will be congruent. If the opposite angles are congruent, that means that ACY and ABY are congruent. And from there, we can say that ACZ and XBA are supplementary to those two angles. And if they're supplementary to congruent angles, they themselves will be congruent. Now if we look at the diagram, since we have two angles, two different triangles congruent, that implies the third angle are also congruent based on the no-choice theorem.